Continuing from the previous video, we stopped on slide 14. This is slide 15. We are introducing the grocery store database that we will use in some of the exercises in this class. You should be connected to the grocery store login at this point. You may be connected more than once. Just be careful of your credentials. Make sure that the things that you do are against that grocery store login and not against some other set of credentials. This database was designed by me. It contains tables that follow the rules in the document that I provided. If you study the rules, you'll recognize column names, table names, and other attributes that help you understand what these tables are doing. You can always look at the design of the tables, which I encourage you to do, but it's useful to have a common naming convention, a common language that we all speak to make our jobs a little bit easier. The database has a list of employees. It has a list of loyalty numbers, which is the little tag that you scan or the code that you enter in when you buy something so they can track you. It has the purchase history of those loyalty numbers, what they bought, how many they bought, when they bought it, what store they purchased it from, the employee that helped them. It has a list of products, which are actually real products that I obtained from an online source who was happy enough to donate those product information rows, and it contains a short list of stores. This is useful for us because it's compact, it's easily understood. We've all been to the grocery store, I hope, and we can have some semantic understanding of what's going on since we all have some understanding of how a grocery store works. Let's start with a question. We've been given a question in the real world. Hey Bill, each employee is assigned to one store. To what store is each employee assigned? I'd like to know what store each employee is assigned to. Where are they supposed to be working? That information should be in the database somewhere. If it wasn't, I'd be doing you a huge disservice by asking you to go look for it. If you're given a question like this, assume that the information is in there somewhere. Assume that I'm not trying to trick you or fool you, but the information is available without an unreasonable amount of effort in the database. Before we do this analytically, let's just experiment and investigate a little bit, which I do encourage you to do. Go back to SSMS, expand the database, scroll down to grocery store, expand the grocery store database, and then expand the tables folder. In the tables folder, you see tables with reasonable names that might help you. If you look at the slide again, each employee is assigned to one store. That might be a good place to start looking. Which of these tables do you think contains employees? Well, the EMPL table could be the abbreviation for employees. Now, if you're not sure, it's okay to ask. It's fine. Post a question in the FAQ on Blackboard, and it will be answered. Eventually, you will get comfortable with this data. You'll have no problem navigating it. But if you're not sure, don't struggle. Ask for the question. Ask for the help that you need. It's always useful to try to browse these tables. Let me do that again. That went by kind of quickly. So, alternate click, right click on the table, select top 1000 rows. And we see that there are 14 rows in this table. If you look in the lower right hand corner of the video, you'll see it says 14 rows. Each row has a primary key named according to our standard, a natural key, which you really can't discern from this, and some other information about the employees. Let's look briefly at the design just to talk about the keys. Right-click, Design. You will get this message. You are not logged on as a database owner or system administrator. You might not be able to save changes to tables that you do not own. You can still continue, not a problem. You're not violating any rules. You're not going to get in trouble. The SSMS will show you the design. You may get another warning. That's fine. And you can see some of the information about the design of this table. Now let's focus on the first row. The first attribute, EMPLID. That is the primary key. How do we know? There's a little key there. The little key means that we have defined, the database designer, me, defined that column as the primary key. Now our rule is that a primary key will always be an integer, and it will always be set as what we call an identity specification. That means that SQL Server will manage it for us. We don't have to do anything. As a matter of fact, we can't do anything. The first row added to the table will be ID 1, the second row will be ID 2, ID 3, ID 4. That's a surrogate key. It's surrogate because it has no value in the real world, and all it does is allow us to create joins between foreign keys and primary keys. So follow that rule. When you create a table, create a surrogate key, name the key as the same name as the table without the lowercase t at the beginning, and an ID appended to the end. If you look at my rules, the primary key of every table is an auto number integer field named by appending ID to the table name without the T prefix. Follow those rules. If you understand those rules and consume those rules, you will be able to read my tables easily. All my tables follow those rules. Now you may be thinking that, hey, we've already seen a table that doesn't follow those rules. You don't have to do this, just watch. The AP database did not follow those rules. Look, there's a whole bunch of tables that don't start with lowercase t. And if you look at the tables, there's no obvious indication of IDs except that one. If you look at the state table, that has an ID, but there are rules that are broken here. That's because this is not my database. This is provided by Microsoft, and it is freely available in the public domain, and it's a good table, it's a good database for you to struggle with. So there are some databases that don't follow my rules, that follow their own set of rules, and that is certainly one of them. Let me clean this up. Okay, we looked at the employee table. We saw that it had 14 rows. We saw that it had, in the design, a surrogate key. Well, if you go back to my rules again, from the previous presentation, if I can find them. I found them. This is slide 7. Referring back to my rules again, we demonstrated in the employee table, every table has a primary key. We should also demonstrate every table has at least one natural key. Flip back to the design again of the employee table. Again, we're back in the grocery store database. There is no immediate indication of what the natural key might be, simply looking at this design. But if we bring up indexes and keys on that table, I just right-clicked in the open space here. Indexes and keys. There's the primary key. Now there's one called IX, which stands for index. And we can see that whatever this is, it is unique. and the column that it references is EMPL. There's your natural key. The natural key is the EMPL column, and it is defined as unique. In other words, you can't have more than one employee with the same EMPL value, and it is referred to as a unique key. Therefore, you can look at my design and you can see the natural key and you can see the primary key. And what about this little guy? This attribute, this column, does not have the same name as the table. It's not EMPL, but it does have ID at the end. If you refer back to my naming conventions, when possible, a foreign key has the same name as the corresponding primary key in the target table. There you go. By looking at this column in the employee table, then you can tell that it refers to the primary key of another table called store. Here we have then a foreign key primary key relationship. This is the foreign key in the employee table, and the primary key that it refers to is here in the store table. We can look at the design of the store table, and there it is. Since the table is called tStore, the primary key is store ID. It's defined as an integer. If we bring up the properties of that column, you can see that it is the identity specification for that table. Now let me demonstrate to you the upshot of having a surrogate key, because it is useful and powerful. I will close all of these windows, and I am going to go to the, let's just go to the employee table, and I'm going to go edit. Now you haven't done this before. You can follow along if you like. Remember, I'm logged in. I'm using the grocery store credentials that I gave to you. So we're using your credentials. If we hover, we can verify that you're logged in as grocery store. If you're not sure, scroll to the top and you can see there's our connection, and it is indeed the grocery store login. But watch what happens. When I try to edit these records, what do I get? I tried to insert a record into the table. No row is updated. The data in row 15 was not committed. If you read through it quickly, you don't have permission to do it. So logging in with your credentials denies you permission to add records to my tables, which is the way I want it. I don't want anyone in the class adding records to my tables, because that would corrupt the results that you would get when you wrote your queries. You have read permission on the tables, you do not have write permission. But for the purposes of this demonstration right now, I am going to use my credentials. So pay close attention, because in the grocery store database, using my credentials, I have permission to add rows to the table. So I select edit top 200 rows. I verify that I am logged in as me, and actually I'm not, so how about this? Let's close that. Let's go here, edit top 200 rows. Now let's try it. Let me do it. I was able to add a row to that table because the credentials I'm using have write permission enabled on that table. But our focus really was the surrogate key. So look what happened. When I put in this row, it automatically assigned a value of 16 to the surrogate key. Let's do another one. $17. So we see that SSMS makes a request to SQL Server to add a row to the table. SQL Server increments the employee ID automatically because it's a surrogate key. We don't have to do anything. Can I put my own number in there? How about if I want to put 99 in there? I can't. I can't even type into that field because it is a surrogate key. It's auto increment. It's managed by the database engine SQL Server. What's the value of that? It's guaranteed to be unique. No matter how many people are using the database, no matter how many records are being added, everyone will have a unique employee ID guaranteed and managed by SQL Server. That's a very valuable thing for us to have because we don't have to worry about creating that key. It's created for us behind the scenes. Let's flip back to our slides and let's resume where we left off. We were discussing this question. How do we determine what stores are assigned to each employee? Again, we are assuming that this information is available in the database. It's not a trick, and you should be able to find it. Since the question we're trying to answer is what store is each employee assigned to, we should probably ask ourselves, is there a store table? Is there an employee table? And how are they related? Then it becomes an exercise in figuring out how the tables are connected. How are they related to each other? So if we look at the columns in each table, and let me go back to SSMS again. Let me make sure I'm in the right credentials. And if I expand the employee table, I can look at the columns. This is just an easier way than bringing up design view. And I expand the employee table or store table and I can bring up the columns. I can see that there's a store ID in the employee table. And based on the way we have named things, based on the way we have named columns, I can be reasonably certain that the store ID in the employee table is a reflection of the store ID primary key in the store table. Again, this is because we're following conventions. There are other ways to verify that as well, which we'll talk about, but that kind of gets us going in a hurry. So we appear to have a common column. If we don't believe our eyes, and we're not quite sure if these conventions are being followed, we can bring up the table design and look at the foreign key relationships. Now you can do this. Yours won't look exactly like this, but you can verify that in the design of the table, the design of actually both tables, the store table and the employee table, a foreign key primary key relationship has been created. Let's try to do that now. Let's flip back over to SSMS. Let's open the design view for the employee table. Remember, we're just trying to verify with 100% certainty that there is a foreign key primary key relationship. Let's go to design. You'll get the message, don't worry. You'll get another message, don't worry. Here's the design of the employee table. Right click and select relationships. Instead of selecting indexes and keys as we did earlier, we're selecting relationships. And look, there are two foreign key relationships defined on this table. These are the names that SQL Server gave, SSMS actually gave to these relationships. The first name is the table with the foreign key, and the second name is the table with the primary key. So if you learn to read that, it helps quite a bit. The first one that's highlighted says it's a foreign key, FK. The name of the table with the foreign key is employee. The name of the table with the primary key is store. And that's just a SQL Server SSMS convention, and it works pretty well. So we can expand the tables and columns category, and there we can see with all certainty that the foreign key table is employee, the foreign key column is store ID, the primary key table is store, and the primary key column is store ID. That follows all of our conventions that were defined in our document, and that tells us with 100% certainty now there is a connection between these two tables. The store ID then is indeed designed to be a foreign key into the store table, from the employee table to the store table. In the next video, we will actually write the query to join the two tables.